Hello, it's Dr. Moore here to help you with the mean and standard deviation problem set. Question 1. Question 1 states, students in a biology class recorded the time in seconds it took 4 different ants to locate sugar water in a large foraging arena. Their results are shown in the table below. And our job is to calculate the mean and the standard deviation. So here's how you would go about that. We'll start with mean. So the mathematical symbol for mean is x bar. And to calculate the mean, what you're going to do is add up all of the observations and then divide by the total number of observations. So we're going to add 11 plus 16 plus 9 plus 22. And we're going to divide by 1, 2, 3, 4. The sum of all of these numbers is 58. So 58 divided by 4 is equal to 14.5. And we want to make sure to include our units on the final answer. This is in seconds. And now before we record this here on the mean line for our final answers, let's just double check with the answers on the back. And sure enough, the mean for the first question should be 14.5 seconds. So we are on the right track with 14.5 seconds. Next, we're going to calculate the standard deviation. And the standard deviation measures how spread apart the data are. The larger the standard deviation, the more distance between a data point and the mean that we would expect. So the first step in calculating standard deviation is to calculate the mean. So we've already got that. Next, we're going to figure out the difference between each of the individual data points, or x sub I, and x bar, the mean. So 11 minus 14.5 is negative 3.5. 16 minus 14.5 is 1.5. 9 minus 14.5 is negative 5.5. And 22 minus 14.5 is 7.5. Our next step is to take each one of these terms that we just found and to square it. That will get rid of the negative sign. So negative 3.5 squared is 12.25. 1.5 squared is 2.25. Negative 5.5 squared is 30.25. And 7.5 squared is 56.25. Now we've gotten rid of all of the negative signs. Our next task is to add all of these up. So 12.5 plus 2.5 plus 30.25 plus 56.25 brings us to 101. We're going to take 101 and we're going to divide it by 1 less than the total number of samples. So we have 1, 2, 3, 4 points in our data set. So we're going to divide 101 by 4 minus 1. That's the same as 101 divided by 3, which is equal to 33.7. And then we have one last step, which is to undo what we did here when we squared it. So we're going to take the square root of 33.7, which is equal to 5.8. That is our standard deviation for this data. And again, before we record it on the line down here, let's just double check that that is correct. The standard deviation is 5.8 seconds. Remember to include our unit here. So 5.8 seconds is the standard deviation for this data set. That means that typically an observation in this population should be about 5.8 seconds away from the mean of this population.